So today we are going to learn about surds. So surds, as I have written, square root 5, square root 10, these numbers we cannot simplify them furthermore. So these numbers are called surds, a number which cannot be simplified more or cannot become out of the square root. If you simplify it, the answer will be in form of decimals. So all irrational numbers are also called surds. So but here I have written another number which is square root 16. Square root 16 will be equals to a whole number which is 4. So this one is not a surd. Let us see the solutions of some questions of surds. So I have mentioned one question number 1. Simplify the following. Roman figure 1 is square root 27. So square root 27 I will write it one side. I will divide it with the smallest number in form of division is 2 cannot divide, so let us divide with 3. 27 divided by 3 will gives you 9 divided by 3 gives you 3, and 3 divided by itself gives you 1. So let us write it, all the factors of 27. We have 3 times 3 times 3, so we have we have only one pair of 3, so it means 3 raised to power 2 times 3 raised to power 1. Here if we count 1, 2 and then 3, we have 3 3's, so 3 raised to power 2 times 3 raised to power 1. So all those numbers which are having power 2, 1 will come out, because the square cancel with the square root. The number which do not have square will stay inside the square root. So the Roman figure 2 is square root 128. So 128 divided by 2 will gives us 64. 64 divided by 2 gives us 32. 32 divided by 2 gives us 16. 16 divided by 2 gives us 18. 8 divided by 2 gives us 4. 4 divided by 2 gives us 2. 2 divided by 2 gives us 1. So here if we write the factors of 128, we have to count the number of 2's here. 1, 2, 3, 4, 5, 6 and 7. So 2 times 2 is pair 1. 2 times 2 second pair. 2 times 2 third pair, and times 2. So next to it is we have 3 pairs of 2 and 1 single 2. So 2 raised to power 2 times 2 raised to power 2 times 2 raised to power 2 and times 2 raised to power 1. If we add the powers, 2 plus 2 4, 4 plus 2 6 plus 1 7. That's what we have upside, 2 raised to power 7 total. So all those numbers which are having power 2 will comes out of the square root. So 2 times 2 times 2, and this one do not have power 2, so it will stay inside the square root. So here your answer is going to be 2 times 2 is 4, 2 times 2 4, 4 times 2 8. So the solution of square root 128 is 8 square root 2. So for the solution of square root 32, you will solve it yourself and tell me the answer in the comments. So now I'm going to talk about some basic rules for the surds. So whenever square root a plus or minus square root b is given, it will never be equals to square root a plus or minus b. It means if they are adding or subtracting, you cannot write them in one surd. So this one is sure you cannot write them in one surds, but in the other way, which are given square root a times square root b, this one can be written as a times b in the one form of square root. Under the one square root you can multiply them, and the same for division as well. When they are dividing each other, so you can write them like a divided by b. So if we talk about some examples, square root 16 plus square root 15. So square root 16 will be equals to 4, and square root 25 will be equals to 5. So this one is going to give you answer 9. But if we think about this one, square root 16 plus square root 25 in one square root, this is going to give you square root 16 plus square root 25. So it is going to give you square root 31, which is not going to equal to 9. So this is proved that you cannot write them in one square root when they are adding or subtracting. So the next one is square root 2 times square root 8. So square root 2 times square root 8, 2 times 8. So it is going to give you square root 16. So square root 16 is equals to 4. So the last one for the third rule is when they are dividing each other, you can divide them in one square root. So 32 divided by 8, 8 into itself 1. 32 divided by 8 will give you 4. So square root 4 will be equals to 2.